Hello everyone. Hopefully everything's working okay. I had to readjust a few things on the stream, so I don't know if the camera's working or the mic's working okay. But hopefully everything's coming through nice and clear for everyone, and you can all see and hear me perfectly fine. Hello everyone in chat, welcome to tonight's live stream. We are live, and this is a live training session talking about AI in Unreal Engine 4. So we're going to go through a variety of things. We'll go through the basics of AI, explain a few things, and answering any questions you may have specifically about artificial intelligence in games and how to set them up and what kind of behaviors you want to try and mimic in the AI system that you have in Unreal. So hello everyone in chat. I can see we've got Angus here. Hello Angus again. Hello Raptor. Hello Monster Gaming Barrett. Hello everyone. How are we all doing? Hope everyone is staying safe and well. What we're looking at today. Did I always have the awesome beard? Yeah, I haven't had a clean shaven face since I was like 19, many times ago. Pretty sure if I shave it off, my wife would leave me. But yes, also it's a bit of lockdown-ish. No, it's a bit of lockdown beard, but never mind. Anywho, so before we get started, I want to just say thank you to every Patreon member for their continued support over on Ryan Daly, patreon.com/Ryan Daly. Thank you to everyone who has supported me over there and everyone supporting me on YouTube members. And if you want to get access to all my videos before anyone else, head over there, subscribe for just $1 a month, and you get access to all of my content months ahead of anyone else. So thank you to all my patrons for their support. Really do appreciate it. Thank you so much. If you want private one-to-one sessions and training or help with your projects, email me at support@ryandaly.com. I'll get lots of emails all the time, and April is getting quite full now, but there is still some slots available for April. So if you want to get a slot in, just give me an email and we can work out prices and things like that at that time. So let's get started, shall we? Where are we going? We're going over here. Whoop. Okay, excellent. Hopefully everyone can see this okay, and it's not too laggy. Right. So as I said, we're looking at AI, and we're going to go through the basics first of all and explain a few things, and then we're going to look at explaining a few things that people may have specifically. So if you do have questions, hold off for a little bit and we'll answer those as we go. But we'll go through the basics of AI and how that works. Let me over to my drink because I'll be talking quite a lot. Okie dokie. So I've just got a blank third person template here, nothing special. So let's go through the various AI. Now, to get started, you want a few things. First of all, you need a character that you need to actually be possessed by AI controller. And that could be a pawn or character, but character does save you a lot of legwork with getting character movement working. So we're going to choose a character, and we call this one enemy. And you may also then want to do an AI controller. So the AI controller class you'll find not in top here, but in all classes down here. And you need a controller class because when you're dealing with AI, you need the controller to control the pawn. So normally you have a player controller controlling the player character. In AI sense, you have an AI controller, which is where the computer decides what inputs the AI has. So I'm going to call this one enemy AI. Let me get my chat up here on this screen a bit better. Okay. And quick question from you all: this show is recorded and will posted online for Patreon members straight away. Otherwise, everyone else has to wait 2 weeks. So Patreon members get straight away. Everyone else 2 weeks later for the archive of this stream. Okay, so I've got AI controller and enemy character. Now, to tell the AI to control the enemy character, in here you've got to go into the enemy self, which is the class default settings. Go to the right hand side, you'll see auto possess player, auto possess AI, and AI controller class. You want to choose your AI controller class from the drop down, and you may want to change auto possess AI as well. Now you got a couple of options in here. Placed in world means it will only possess it when I drag it into the world like this. If I'm spawning it during the game, so if you've got like some spawning AI in the game, you're going to want to change this to spawned, or what might be best is using it as placed in world or spawned. I don't know why they don't let you choose this one by default, but it makes no sense. But there you go. You probably want this one. I do see a lot of people ask the question like, I'm trying to spawn my enemy AI into the game, but when they spawn, they just stand there. It's probably because of this drop down. They have not changed. I hit compile and save that. Well, let's give it a mesh so we can actually see it. Makes it a bit difficult if you can't see it. What one is this? This is the animation start back. Yep, good. And we'll do. And we'll turn it around. There we go. Cool. Okay. So, that's our AI hooked up, okay? And we can drag him into the world. Okay, and that's him. Now, for him to actually be deciding what he wants to do, we have to set up a behavior tree. Now, behavior trees are the system that's in Unreal that determines the decision making that the AI is doing. So you have the puppet master, and you have the decision making going on by the puppet master. So we can create a new artificial intelligence behavior tree, and we'll call this one enemy AI BT. And the behavior tree is pretty simple. We'll go through it in more detail in a second, but we need a new blackboard as well. So click new blackboard, and we're going to name it enemy blackboard. And the blackboard is used because when we add tasks in this in a moment, tasks can't communicate to each other. So the only way to transfer information between tasks, the AI controller, behavior tree, is for something called a blackboard. The blackboard is a temporary location where you can store information temporarily so they can access it and read it and write to it. So you click on blackboard and you'll see up top here all these keys down here. So there's your behavior tree and your blackboard. And as I said, the behavior tree is used for decision making process. So if you want your AI to decide what to do next based on circumstances, this is where it happens. And this is probably where most people get confused by. So let's go into talking about how the behavior tree works. Now the behavior tree has a node system, and it starts with a root. Now the root is where it starts the system off. Then you can drag off this bottom rectangle here and drop down, and you can add a selector, a sequence, or simple parallel. So let's go for the selector. So a selector node will always select the leftmost path. So for example, if I had a sequence here and another sequence here, the selector will always choose the left-handmost path first and foremost, and only that one. The only chance it would ever go down to next ones is if that one fails. So if this fails for whatever reason, or aborts for whatever reason, then this will break up, go back to selector, and then go back down the next one. And likewise, we can have another one on here, and if this one fails, it'll go down the third one. So it goes from left to right, and that's signified by these numbers. And you can see that one's 0, this is 1, 2, 3. And it's just a way of it tracking, and you can see the numbers change as I move things about. The sequence node is a node that plays all of its contents in a sequence from left to right. So rather than the difference between this and the selector will only play one, where a selector will play all of them until it fails. Now, if it has a series of content in here that one of them fails, then the whole sequence fails. Therefore, going back to selector and choosing the selector to choose the next branch. That's that. So we can usually, when you're doing behavior trees, you usually start them off like this, because you usually want a decision making bit to happen first, and that's usually the selector here. The sequence is a sequence of events that happens due to that selector. So let's talk about getting it just to move about in your scene. And this is all basic stuff, and probably if you've seen my AI stuff, you probably would have seen this stuff similarly. So it's got a lot of covering the same ground, but maybe better explained, maybe. So this sequence here, we're going to make it run to a location. Now, what we can do for this is create a nav mesh first of all, and more about the nav mesh in a moment and how that works. So we drag the nav mesh bounds volume, and you want it to overlap the whole level. So once you've dragged it in, down here you'll see brush settings. Just extend it so it fills up the whole entire level. Hey David, hey Jordan, thanks for joining us tonight. Once you've got your nav mesh in there, hit P on your keyboard and you'll see a preview of your nav mesh and the space it's taken up. So if it's green and unbroken, that means it can reach it. Okay. Now this square up here is broken off, so it can't reach it from this other island. If you want the two islands to be connected, you need to use a nav link proxy. If we have time, we'll explain some of that later. Okay, and also we can change a lot more about the nav mesh. As I said, we'll cover the nav mesh a bit in more detail later on. But that's that. So let's go in and create a task for this. So the tasks are set by up here. Go new task. And we're making a new task because I know this one does not exist. So with this new task, we're going to need to create a new event. Now the events you have are pretty basic. If you go to add event here, you can see them. You've got in AI. You've got receive, execute, abort, and tick. You want to use receive, execute AI. So this happens when as soon as the task is triggered, as soon as the task is played off. So once it's playing, this execute AI will trigger and do whatever it wants to do. So in this case, we want our task to be handling, just finding out a random location near the enemy. So I'm going to take the controlled pawn here, and I'm going to find a random location. Type in, so random, maybe not from that side, just to find random, get random, get random. There we go. And you got get random point in navigable radius, and get random point in reachable point in radius. And do navigable one. This is saved, don't worry. This is archived for everyone thereafter. So you, on Patreon, we'll get access to it straight away. Everyone else can access it in 2 weeks' time. Okay, so get random point navigable radius takes an origin point, so a location inside the world. And we can use the controlled pawn here. And the controlled pawn is just a generic pawn reference. It's not a reference to the exact actor that we're using. So from here, we can get actor location. And that go into our origin. The radius is how far away do you want it to look. So in here, we're going to make it look 1,000 units away. Don't worry about nav data and don't worry about filter class. On random location now, we now need to save that location out to our blackboard. So I'm going to come out of here and set blackboard value as vector. Now, our blackboard value as vector requires a key. This key is going to be a variable. So if you drag this out, you can just click promote to variable. And there you go. And we call this one vector key. We're then going to plug that into our set blackboard. And then we need to end it. And the way we end it is with a finish execute. If you don't ever do this, it will never ever leave the task. It will just stay in the task and get stuck there. So once you're finished, you've got to tick either success or not success. If it's not successful, then it will just finish execute and fail. So in this case, we want to succeed and tick yes. Compile and save. Oh, almost forgot. With your blackboard keys, you want to get in a habit of making them editable. So tick that as editable. We're going to close that and we're going to rename it. And I'm going to do this one as find random location underscore task. Pardon me. Right, back on our behavior tree. We can now use that same task we just made. So I've got find random location task. That's our one. And in there, we can set the vector key that we had set up. The blackboard key is just a temporary location that we're storing. So this is just a value that we're storing it, and it's exposed to the overall behavior tree. We need to tell the behavior tree to set that to a particular key inside of our blackboard. So we're going to go in here, go new key, and choose a vector. And we call this one target location. Hit save. Go back to our behavior tree, and we can now choose the vector key that we have from the drop down. And that searches our blackboard for applicable blackboard keys. And target location is one of those. So we can choose that one like so. We're then going to use a move to. So we're going to drag down here and do move to and choose the move to blackboard key as target location. Hit save and you're done. So the last thing you need to do is to run this behavior tree. And that happens on the AI controller. So in the AI controller, go to the event graph, and begin play. We're going to do run behavior tree. And we'll choose our AI behavior tree. Now note that this is actually a variable that you can actually set. So if you want, you can have multiple behavior trees and separate them out and make the enemy just switch between them based on circumstances. So in a moment we're going to do it so when it sees the player character to do it on the same behavior tree. But you could in totally make it a separate behavior tree and go to that one instead. We'll talk about the pros and cons of that in a moment, but that's one option you can do. So we're going to hit save and close that. Hit play, and off he goes. Okay, now it's just randomly running around and just finding random locations. He just keeps on going. Okay, and that's it. So let's get him so he looks for the player. So when he sees a player, we need to store that value on our blackboard and tell him to run towards the player. So we're going to go and create in our enemy AI the perception system. So you can set up perception on the enemy, and that regards their senses. So things like vision and hearing, as well as touch as well. So we're going to go to add component, and we're going to search for AI perception. And you don't need to add a stimuli source for your player character. Quite commonly, people think you have to, but you don't have to. It is in there by default. Unreal done that for you. You don't have to worry about it. So on AI perception in here, we're going to go to the right hand side and you see senses config. This is where you set up the different senses that it has. So let's just start off with just the sight one. There we go. And open it up. In here you've got sight radius, so that's how far away they can see. Lose sight radius, so how far away do you have to be they lose sight of you. And the peripheral vision half angle degree. So from directly in front of them and that halfway out, what angle can they see? So 90 degrees is quite wide. That makes it means they have a 180 degree cone of vision. So I tend to turn it down a bit. So I'm going to turn it down to something like 45. So that's far more narrower. It's like more like a 90 degree angle in front of them, like so. Now for this, you want to make sure you tick on detection by affiliation as them all. This system is really dumb. They show you the tick boxes here, but you can't actually use it unless you go into C++ source code. So people often ask, like, can you do a tutorial on these and like show you how to use these? Can do, but it involves going to the C++ code and showing it there. Don't know why it's not exposed. They're just not exposed it at all. But yeah, so just tick them all on, and it saves you a lot of headaches. And we are good there. Let's hit compile, and we can then go to add a new event on here. By going to AI perception, right click, add event, and you've got these various options here. You've got on perception updated, on target perception updated, info updated, component activated, and component deactivated. We want to do target perception updated. This one gives you one single stimulus and one actor. The other one you might often do is on perception updated, and that's basically anything at all gets updated. It'll do it all. But it's not great. I prefer to use this one. And you can break out and check which stimulus was set off as well. Not a problem. You can do that quite easily. So if you want an enemy to only react to hearing rather than the sight, you can totally set that up here and do something different based on that. So on here, we're going to check the stimulus and break that out. So take that out, break. And you can see the information you get from the stimulus. And another thing that people often get wrong about the AI perception is that this is triggered both when it sees you and when it loses sight of you. Okay, very important. It happens both times. That's why you get the successfully sensed here. Either yes, it saw you, or it didn't see you, or it loses sight of you. And the actor here is the actor with the stimulus that got set off. So in our case, it'll be the player character. I do see questions, by the way, coming up. I will answer them in a moment. Don't fret, I will answer those questions. Okay, so in here, we're going to take successfully sensed, and we're going to plug that into a blackboard key selector. But first of all, we're going to check that the actor was in fact the player character. So we're going to drag that out, do equals to get player character. Otherwise, enemies will start triggering off each other because they're characters as well, and they therefore also stimulus check. So that will go into a branch like so. Next, we're going to get our blackboard, and our blackboard we're going to set set value as vector. Plug that into true, and in here we get the key name and the vector value. So the key name is the name that you have to type in for that it belongs to the blackboard. So drag this out and do make literal name, and you want to type in the exact thing in here. Now for this, we're not going to use I just realized I don't want to do vector. Whoops. We'll do that in a second. In here, I'm going to take the name as target actor. The blackboard we want to do is set value as object. Now I want to store it as an object, and I'll explain that in a moment when we get back to the behavior tree. But the object is very different from the target location, and I said we'll explain that in a very short second. So the object value here is going to be either the player character or nothing. Now the easiest way of doing that is using a select node. So let's drag this out and do a select, and you will see the select object option. Choose this, and here we can plug in our successfully sensed. What a select object does, or select nodes in general do, is if the boolean is true, it will choose the A value. If it's false, it will choose the B value. So if it's true, that means we've successfully sensed the player. Therefore, we want A to be the player character. So I'm just going to move this across and just get in our player character. If it's false, meaning that we have not seen the player, we want to clear that value. So just leave it blank and that will clear it. And that is it. Hit compile and save. Now go back to our blackboard, and we're going to add that target actor object. So target actor. When you do make an object class blackboard key, make sure you do go over to the right hand side and change the key type base class. It's hidden, so people often lose this. From base class here, just change that to actor. Makes it a bit easier. Now, the reason why you choose target actor rather than target location, you make it so like, why don't you just give it the player's location, and why not just give it the player? Reason why is that the behavior tree's move to function works quite nicely with actors. The sense that what happens is if it sees if it's given a location to run to, it'll just run to that location no matter what happens. If it is an actor, it'll constantly update the location of it where it's going to based on that actor's location. So it is real-time updating where it should run. So it will basically follow that actor. So if I go in here and we're going to do another sequence in here. And this sequence here, we're going to drag out and do move to. And this move to, we're going to change the blackboard key to target actor. Now, how do we get to this sequence? Well, we need to abort this sequence when that value is set to something. So on your first sequence here, we're going to right click and add a decorator. Decorators are essentially like gates. They will do something as the flow goes into the task. So in this case, we're going to use a blackboard decorator. And it is essentially like a gate. It will either be open or shut. And if it does shut, you can tell it to abort the whole tree. So click on the blackboard decorator, the blue bit. And you want to go to the right hand side and choose a blackboard key, target actor. And you want it to only allow flow through this if the key query is not set. So if target actor is not set to anything, it'll do this stuff. Now, if that is going to change and like it does see the player character, we need to tell it to abort. So on results change up here, change it so it says observe aborts both. And what that means is if it's in this part of the tree and it sees the player, it'll abort whatever it's doing here and then do this bit. And likewise, if it's doing this and it stops seeing the player, it will then go and do this. Now, if you want it so it runs to the player's last known location before it gives up, just change this to be self. That way, it won't ever abort this. It will just do that, and then it reaches the end. And when it reaches the end, it will do this. Okay? But I'm going to leave it as both for now. Hit save. And then to push play. And here he comes, chasing after me. Okay. He lost sight of me now. Okay. Hello. Okay, so there you go. That's AI moving around, chasing the player quite easily. Okay, so let's take a moment to answer some questions that people have. Hang on. Okay, so we've got Carter Kitchens. Could we ever do a live inventory system? Yeah, one day we will. Yes. Ryan's a genius. Oh, thank you. Can you do animations in Unreal? Like posing a character? Yes, you can. Using the control rig mannequin, you can do that. If you don't know what that is, you can download it from the marketplace from Epic. And it's a control rig setup so you can control the posing of actors for animations. It's not ideal, but it's not bad. Kristen, isn't AI Move 2 node better than Move 2? So this is using the AI Move 2 node. You can't see it, but that is you. I know one you're referring to. You're thinking of this. That is the same as the other one, except the difference here is that this is not on a decision-making tree. So you have to set up complex blueprints and pathing and branches, things like that, to decide when it wants to do this. We could mimic the behavior tree on a blueprint, but behavior tree is far easier and far neater way of doing it. So yes, you can tell you it's exactly the same. It's no different. They just call it Move 2, but it's this. Okay, AI Move 2 is BP node. No, yeah, there you go. How does Final Fantasy X do their AI follow with the main character? Essentially, it's the same thing as what we just did there. So, even though I called it enemy, it's just we can just make him not. Hang on, let's make him just follow the player character. Hang on, let's go into the behavior tree here. And if I wanted to do that, I'll just move this over here. So it just does this one, move to target actor, and just give it a target actor of the player character. So rather than doing all this junk, I'm going to disconnect that, and at start here, get blackboard, set target, set value as object. In fact, we'll just copy this. Be a lot easier. And the object value is get player character. So it's always set to the player character. It doesn't ever change. It's always that. So it should just run towards me the whole entire time. And now I've got a party member just following me around. Yeah, that's it. And you can have multiple of these. So if I want multiple of them following us around, I go in there, just duplicate it. Here they all come. Okay. So another thing that you guys may want to know about is how to make AI avoid each other. So at the moment they'll just try and collide with each other and take up the same space, which is not ideal. There is a simple way of doing that. You just go into the enemy character and go to the character movement component. And if you scroll down all the way here to avoidance, and you tick use RVO avoidance. Tick that. Compile that. And now they will adjust and avoid each other. And do stuff like this. Okay. So you saw that one just walk around you. You can do just a simple avoidance like that. Now, you'll notice that their rotation is a bit jittery, and that's because we haven't told them to focus on us. So that's quite simple to do on AI controller here. I can just do set focus and just set a new focus to the player character in this case. And they'll always turn and focus on me. Now, I'm going to change my spring arm on my character so it doesn't collide, because that's quite annoying. Turn that off. Hit play. Okay, and there they go. And you can have a whole horde. Right, here we go. Let's just select loads. Boom, boom, boom. And you have a whole horde of them just constantly try and follow you. Like groupies. There you go. And you can see where they're trying to avoid each other. It's not the best system. So you want to avoid doing this sort of crazy stuff at all times. And it looks like they're gliding because the animation system isn't set up to allow for them to move freely. But yeah. If I can jump up here. Oh, right. There we go. Right, there you go. So, yeah. Avoidance. Pretty cool. Right, so another thing you may find as well that might be a bit annoying. Not annoying, but a thing you want to change. Let's just clear some of these out because it's ridiculous. Right, do that. Okay, so notice that when I run up here and jump down, right, as you saw them running up them stairs, don't if you notice, and I jump down like that. See how they're running and sort of sidestepping because they're focused on me and will remain focused on me. Now, what you may want to do is make them so they don't do that, because it looks weird where they're sort of sidestepping down the stairs because they're constantly like tracking your eye line all the whole time. You may want to change it so that they look where they're running, so they don't trip up over themselves because it looks just odd. So the way you do that is you go to the enemy AI, and we've got to set focus on the player character, okay? But what you may want to do is just to set the focus on where it's going next. So for that, you can get, see if I remember what it's called, navigation, get, which one is it? It is get path. Get current path. I think it's this one. Did I do it this one? I can't remember. Well, I did now. Path. Navigation. Find path to vector. You get current path. Ah, crap. What's it called? Is this one? Get current path points. Yeah, I think it's get current path points. And controller is self. And you get the first one on the path point. So get a copy and leave it at 0. And the new focal point. So set focal point will be on that vector. And that way it will always look at its next step in the path rather than at the player actor. So let's see if we can test that out. Let's looking at 0, 0. That's broken. Hang on, let's double check that. What was this called? I can't remember what it's called now. Get path. Navigation. What one is it called? Get. I have to look it up. Well, I did another one. I did it in something else. But you can get like the path it has, and then you get what next point it's looking at for. Get path following command. Get path cost. Get path length. Partial path. Ah, crap, I can't remember what it's called now. I'll have to look it up. But yeah, you can get the path point that's going towards next and set that as a focal point, and it will look then where it's got to go next, whether it's going that way or not. But anyway, okay. Right, I'm going to put this back the way it was, where we had it chasing the player. Hang on, let me put this all the way back. It was. And close that. And go in here. Yup. Oh. Unfortunately, I can't remember every single thing. Okay. Yeah, Nick, as you're saying, as long as if you've got orient movement is checked, you can just leave focal path blank and it will just run whichever way. It will turn whichever way it's running. That is correct. Yes. JMB, is behavior trees better than using AI within Blueprint? Yes, it's quicker. Well, it depends. It's if you're doing complex AI, yes. If you're not doing complex AI, you can do it without it. So you use a behavior tree for decision-making processes. Okay. Okay. So, that's that. Okay. Now there are other different sequence decorators on here. So you right-click and you go see Add Decorator, and there are different ones available to you as well here. Now you can also make your own custom ones as well. So to make a new custom decorator, you click New Decorator up top. And you're presented with a very similar looking thing as the tasks. Difference is that you want to go to the left hand side functions, click on override, and these are the various values that you have available to you as functions. So in here you've got execution start and execution finish, condition check. So you want to say do a particular check to see if you can actually go into something. You can do perform condition check. So in here we can do perform condition check AI. And do something on there and say whether or not, yes, you can actually go out of it. So you can also create your own custom decorators. How would you do flying AI? Now, flying AI is tricky. Now, the problem with... I'll show you an example of flying AI. But it is a bit of a cheat. It works as well for fish and things like that. I'll make a simple pawn. And we'll do flying AI. And in here, we'll give it a simple mesh. Like so. And pawn. Put in pawn movement. Done. Can fly. Ticked on true. Okay. So this dude, we're going to make our flying AI. Now, as I said, this is a cheat. What you're doing here is on tick. You just do... Or not even do it on tick, maybe. I can't remember if you can do it on tick or not. But you can do a begin play, at least. Go AI move 2. And the pawn is itself. No, it's not this one, sorry. It's the other move 2. Move 2. Move to location or actor. There you go. And the controller, you do it here, get controller. And self. The goal location will make the player location, so get player character. Get actor location. And pop that in there. Yeah. Or a goal actor. The goal actor might actually be better. Plug that in there. But what you want to do, if you drop the advanced options, turn off use pathfinding. And what that'll mean is it will now track me without using nav meshes. The problem that has is that it will clip through stuff. And I have to turn its collision off. Hang on. No collision. So that's on begin play, so we have to put on tick. Pretty sure we do. Can't be if I don't have tick before or not, but because it wanted updating the location. Yeah, there you go, and it will fly with you. So I may want to do a location rather than the actor, and the benefit of doing that is I can set get location. I can add a value to that of say 200. Plug it into goal location, turn it off, and hit compile. And he'll fly. Should do flying AI. Goal location. Why not working? Do I have to have that plugged in as well? Shouldn't do. Hang on. That should work. Why is that not working? Let's turn the radius down as well. Or up rather to 100. Stop and overlap. We'll say no. Use continuous goal tracking. Not having it, is it? You think that what did I do last time then? I've done it for my game, my Project Aurora game. The character does the same thing. But it does something similar to that, where it just follows a location, and you can make it do random stuff too. So do like a begin play. We do custom event in here to fly. Pop that in there, and we'll just do a random location. So get random. We'll get get location. Get actor location. Then we're going to get a random unit vector, or no, just random vector. And that gives us a random direction. So if I multiply this by a distance of, say, I don't know, 1000, and add that to it, plug that in there. On move finished, take it to fly again. And on begin play, fly. So it goes to fly. When it reaches this point, it will then stop flying and move around. Although it's not liking not using goal actor. It should do it. Oh, am I doing me on? Let me look up what I did in my one. Hang on. And I'll show you. Hang on. Project. What do they call it? Platformer. Yeah. I've got it in my game. I can't remember what I've done with it now. It's something like that. While that's loading up, let's answer some questions. Hello Ryan, what about multiple enemies holding a distance between themselves while fighting the player? So you need to tell them to offset the location they get from the player character. Right, let's have a look at what North Star does here. North Star, I'm doing that's rotation. That's not going on there. Go to AI controller. Move to location. Oh, I'm used to seeing move to location. That's why. Okay, so if I go back to my flying AI, move to location. That'd be from the controller. Move to location. There we go. Destination. And to do that, turn off pathfinding. 100. Yep. Oh yes, a loop. Whoops. Needs to be a tick. There we go. Yeah, he's just finding a random location. But he's running around Maniac. He's now underneath the map. Yeah, just finding a load of random locations on tick. I think I slowed it down in my one. Hang on. I'll do my one. Yeah, I said when the player moves, tell him to move to a player location randomly. But yeah, there you go. That's the trick around it. You just turn off pathfinding. But it means it doesn't have pathfinding, so it won't navigate around objects. For that, you need to create your own nav mesh system, which is not easy. There is something on the marketplace though that does it. So by all means, check that out. Okay, I'm going to get rid of that horrendous mess. Okay. Okay. So how do we do reputation based one? Okay. Well, let's. I'll tell you what. How about we get AI to have a leader, and also have reputation as well towards you. So I'm going to create an enemy here, and this enemy. Let's get rid of this decorator. And in my enemy here, we're going to have going to change their material based on their team and leaders and things like that. So let's first of all focus on leader. I'm getting too ahead of myself. Let's do leader stuff. Okay, so let's do a leader system. So we've got AIs out here. Okay, now we want one of them to choose to be the leader. So if I want to be if I want to be directing it by myself, the designer, what I do in here is I'll go to the variable list on this and go my leader and hit and change this to a character and make it editable. And what you can do on this is one way of doing it. You can click on each one then and choose from the drop down the leader. Okay, now that's one way of doing it. The easiest way of doing it though would be to change the context of this to be am I leader? Or no, I guess no. We'll do it as leader here because I can have multiple teams then. Right, leader. So I'm going to say this one has the leader of the middle one. And this one also is following this one. This one has no leader. Okay. So what we're going to do on that enemy AI is at the start of this, we're going to get the pawn of this and store it. So get controlled pawn. And it's a good idea to do this at the beginning play, because then you can cast to your enemy and store it as that reference. Okay, so now we've got that reference to the enemy. We can now read who the leader is. So what I can do here is I only want to do this if I am the leader or don't have a leader, basically. Because if you don't have a leader, therefore you are the leader. So in there, we're going to get the as enemy. And we're going to check whether or not they have the leader. So get leader, convert to validated get. And you only want to do this if this is not valid. Okay. Otherwise, we're going to set basically the same thing over here, like that. Int is valid, but the object value for this is going to be the leader. So if they go with that one. So if the enemy that is running this code has no leader associated to it, it means that it is the leader. It will then be not valid and therefore will chase the player when they see the player. Once it's doing that though, and the others see it, the others will then see as enemy if that is, I do have a leader set, it will then say to follow that leader. So for example, we haven't finished yet, but for example, if I get seen by the leader, I don't know which one's the leader. Hang on, this isn't useful. Let's go and make the leader a different color. Let's go in here, make a color system. And get that out. Put that to that. Oh, what's it called? It is called body color. Oh, is it not an instance? Crap. Okay. Hang on. Let me just get through this bit. Create dynamic material instance. Choose the body. What's it called? UE4 man body. And take that out of there. Oh. And this is going to be body color. So I should be able to change this in game. Like that. The other two are black because black's the default color. Okay, so he's the leader, so he should follow me wherever I go. And oh, hang on, let's increase his perception a bit. Right, so he should. Oh, it's not focusing. Hang on, I've got to turn to focus. Hang on. I'll tell you what we'll do is make a new task on here because that'd be better. So make new task. Easy task blueprint base. Execute. There. And not that one. We'll execute AI. Execute AI. There we are. And controller, set focus. And this will be get player character. And finish execute. Success. Focus. And on here, do focus, then move to. Right, that would be better. That working? Yeah, there you go. So those two are now following him, not me. Okay, and if I want to say that they are following him and not me, if I change this task for the focus to use a blackboard key instead, target key, blackboard key selector, editable, and there, get value as object, then cast to character, and that'll be the new focus there rather than player character. So it'll look at whoever they are been told to focus on. So on here we can change that to be target actor, so whoever they're running towards they will now look at. So the one in pink should look at me, the two in black should look at the pink. There you go. So they follow him because he's the leader. Okay, so that's how you do leadership type stuff. You can set leaders on individuals like so. If you're looking at more randomize it, you'll want a overall directing AI class. So like another managing class that sits above all this, and they are directing everything that's going on here. And that's usually how you handle combat. Is you usually have another class in here, and we'll say it's an actor, and this is the AI director. And we can say randomly it will choose one of the three there as the leader. So on begin play, I'm going to get all actors of class, choose the enemy class, and get a copy. And in here we're going to get random. Oh no, not get random, just type in random. Random integer in range. And we'll say the random one is the length of that. No, not length, sorry, last index. Okay. And now I'll find a random integer. Just pick one of the random three. Now, with that in mind, we want to set that as the leader and not anything else. So now this will involve changing how we set up our code before. Now, previously we set up our enemy so we can pick the leader. In this case, we want to say, we'll say in here, oh no, we'll work with it. We'll work with the same confines as that. Well, I won't change it. So for this, I'm going to do a for each loop, or actually store this value here as the leader. Promote to variable, leader AI. Like that. And then I'm going to take this array here and do a for each loop. And for each one, I'm going to check whether the array element is equal to our leader value. If that is the case, then I don't do anything. If it is false and it's not equal to a leader AI, I'll take this and set leader to the leader AI. Compile, save. So what it's doing there is it going through each one, checking whether it matches the random one we picked out. If it does equal it, then don't do nothing, just leave it blank. If it does not equal it, meaning it's not the leader, we're then going to set its leader value to our leader that we chose randomly. Compile and save. So once you do this, you then want to tell it to update their colors based on that. So you may want to, on completed here, actually no, we could do on our enemy here. On the I'm just going to we'll take this off of here and promote that to a variable, and that is our dynamic material. And put this on the event graph for begin play. Copy that into here. So what I want from this dynamic material would be the self. Begin play, we're going to put a little delay in it. So it gives a chance for the director to do its thing. Little delay. And after the delay, it's going to go into here. Then the value here is going to change based on our leader value. So we're going to drag leader out, choose get, right click, convert validate get. Plug that in there. And if it is valid, meaning it has a leader value, I want to change this to be, we'll make it red. So reds are for followers. And if it is not a follower, and i.e. a leader, we'll make it green. Okay. And that'll do there. So I'm going to drag in my AI director and put play. And it chose none of them. Of course it didn't. What did it do wrong? Get class of enemy. Get random last index 2. Yeah, it should worked. Get leader AI. Oh wait, I've got to actually tell the leader AI. No. Leader AI. That should work. What have I done wrong? Delay is not valid. If it is valid, it means I have a leader. Make it red. Oh, not that one. If this is equal to the leader AI, let's just print string this. Oh, it worked now. Why didn't it work before? Enemy 3. Maybe the delay isn't long enough. It should be. Delay by 1. I don't get why that's not working. Why it's not working? None of them's leader because they can't see me. So one of them not getting assigned the leader to be the leader. Right, pitch string. This should only fire off once because there should only be one leader. Hello. Yeah. well confused. Why is this not working? Fires off once. Begin play. We'll do leader. It's not valid. Print string. I am the leader. Now I work that time. Oh, wait. It's because I've already got them set here. I'm such an idiot. There you go. Now it work. There you go. Yep. My fault. That's my bad. I'm an idiot. It's always silly mistakes. It was just code I left there before. But there you go. Okay, so one will get chosen randomly to be the leader, and then they'll follow me, and the other two will follow the leader. Okay. So you can do stuff like that. So what about if you want to change allegiances? So at the moment, these guys think of me as the enemy, okay? They've trapped him in. Well, these guys currently think of me as the enemy, so therefore will chase me. But what if I want them to change their allegiance based on a value that the player has, like a reputation? So what I can do here is on the enemy AI is make this leader follow the player character, so long as the player character is of a certain reputation level. So what I'm going to do here is go to the player character and give it a base value here for rep level, and that'd be a float. And I'll just do a simple key press for this thing, so do like a 1 key. Take rep level and we'll increment it. Okay, and we'll just print string it as well. Why not? Okay, so when I push 1, his rep level should go up. Yeah, and what I can do is I can set a rep level that they need in order to chase me. So I can go to my behavior tree here, and we're going to do it on here. So we got, let's get organized on this. So we're going to rename this one to be chase player, and we're going to also change a value on this, and we'll do it. What would be the best thing to do for this? We want him to run away from the player. Or basically abort this if yeah, we'll make it abort this if the rep level is a certain value. So for this, we're going to go and add a decorator, and we'll do blackboard, or we could do a service instead, I think. So a service, got a new service here. We can do, on the service, we can do a tick. And on the tick, we can get the player, or actually not on tick, we'll get also on activation. On activation, we'll get the player character cast to the third person character and store that as a reference. Oh, hello. Then on tick, I'm going to take a look at my third person character and look at their rep level. Get rep level. And if the rep level is above 10, we need to tell it to abort this whole entire branch. No, finish. No, what's it called? No, hang on. Deactivate. No. What do I want to do here? I want to change. I want to change the target actor, don't I? So on here we'll do set blackboard. Ooh, blackboard value as object. And the key here we'll do we'll just do a variable target key. I think this will work. We'll soon find out. If not, I'll do it another way. Plug that in there. We're going to set blackboard value to nothing for target key. Make that editable. And we can check this. So if I do a print string for this, we can tell it to print string the rep level that it currently has. I'll make it a different colour as well so you can see it a bit clearer from everything else. Compile and save. So this service, okay, is a block of code. Check rep level that you can attach to other nodes. So here I can right click, add service, and add check rep level. And target key we're going to change to target actor. Remember, target actor is set to abort both if it changes, and this is observing it. So if this changes to nothing, this should abort it and cancel it all out. So this should, in theory, work. Hit play. And you can see the tick going on there, 0, 0, 0. Hit 1. It goes up. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And off they go randomly. They're still looking at me because the focus is still going on. But now the rep level is nicked over across. And now, service there, you see it's still ticking. Well, not still ticking, but it will tick. You can actually control how often it ticks. Well, with it, you can go over onto the right hand side here and change the interval. So this checks every 0.5 seconds. You can increase that, decrease that as much as you like. But this is basically saying when it's in this branch, it will run this code on that tick event here. Activation is when it's first activated, it does this. And tick event is basically when it ticks. You also have deactivation, so when it leaves that branch and deactivates the service, it will close the service out. Think of it as a service as a block of code that you're running on the whole entire branch. So whilst it's in this branch somewhere, it will run this service. And once it leaves it, then it will deactivate and won't do it anywhere else. So it's a good place to do things like this, where you're checking values all the time to see if anything's different. So here we can make them lose focus as well. So we'll do a find random task here. We'll take the owner controller and we'll do clear focus. So again, here they are. He'll chase after me, and now increase my rep level to about over 10, and off they go. Okay, so you could do something quite simple like that. You can also change it so what side you're on as well. So we can change that around to keep an eye on looking at the player's affinity towards these other AI. Are they friendly? Are they not friendly? I just use a value, but you can use it as an enum, for example. You can do as I don't know, whatever you want really. Okay. Spectra Blaze. There's probably a simple answer to this, but how can you have pathfinding with enemies that can jump over obstacles? Okay, so jumping over obstacle enemies. I want you to do a little exercise right now, and I want you to think about all the games you've played, and I want you to honestly try and remember how many games had enemies jumping over stuff. It won't be that many because it's damn difficult, and it looks weird if it goes wrong. Essentially what you do is you have to tell the enemy to run to a certain location and then play an animation to jump up or climb over stuff. and those locations are usually set up as nav links. So you tend to go to a nav link proxy to climb up something, and then you play an animation, which is usually root motions, to climb up over something. This is something that's not usually included in games because, especially mid-tier to low indie games, don't include it because it's a pain in the arse to implement. So it's usually reserved for like the top end, like Last of Us type games where it's like big money, big people. You can do it, just it's a pain in the butt because you have to do the root motion animation, and if you don't set it up correctly, it can look janky and weird. So beware of that. Okay. Now, I think we're going to bring this nearly to an end in a moment. Now, we've only just scratched the surface. There's a lot of other stuff as well. Like, we didn't even touch the EQS system or anything like that. But I've got videos on EQS, so by all means help yourself to those. That's totally okay. I'm going to go through and show you a couple more things before we end up. If you do have any questions about AI, throw them in the chat right now, and we'll answer whatever questions we have as best we can, okay? So the thing I want to go through here is we're going to go into our behavior tree, and let's say I want when doing a random location task, is going to make them change the location speed, the movement speed of the player. Okay. So on here, we're going to go into the task here, add a new variable, call it move speed, and make that a float. And we'll give it a default value of say 400. Actually, no, 300. Now, once it gets into this task, we're going to tell the task to change the controlled pawn here, movement speed. So drag this out, cast to character. And it has to be a character because you're using the character movement component. Oh, pardon me. And in here, you're going to set movement, max walk speed, sorry. Max walk speed. Oh, we have to get character movement component first. Get character movement component. Set max walk speed to move speed. So now our move speed, we can turn this eyeball on, go to our behavior tree, and we can change the move speed that we want to be used for this task to 300 if we want, or anything else. Now if we move it back to running speed when it want to chase the player, I'm going to focus here, and I say on cast a character for focus, we're going to tell it to here, character movement component, set max walk speed. I'm going to set that to 600 because that's how fast they run normally. So set it to 600. Compile, save. So now they'll run after me, and if I can lose sight of them, they go slower. Notice that? They're going a bit slower. But now you see me, he runs after me. Those dudes are still going quite slow because they have not seen... no, they should still run fast. Why are they not running fast? Oh, it's probably because their focus is failing, probably. Oh no, this is failing in total. Get controller. Okay, that is. Yeah, no, I've got that wrong. Yeah, it fails it. The target keys failed because of it. But yeah, nonetheless, that's how you can change speed. If not, you can make them separate tasks. As I said, Shimura, if you want enemies to jump, you have to make the animation for them to jump and launch themselves. So for example, if I have a navlink proxy here, if I turn P here, you can see it. So here's my navlink. If I want my enemy to climb up and jump up on here, like that, when they run to that point, they need to then launch themselves up there. Now to do that, I'll have to normally do a climbing in motion rather than a jumping motion, because jumping is quite hard to nail down. At that point, a climbing motion needs root motion. I don't have a root motion animation to do this, but you make them get to this point here, and they will launch themselves up on it. Because on our nav link, you can. If you don't know what navlink does by default, by the way, it tells that the two navigation meshes are connected. So if I put this one here and this one over here, as long as it's inside the nav mesh, hit play. He should come with me, and he should follow me off the page here. Okay, they find a nav link and then follow it down. Again, if we go up here, if I fall off this, it'll run round and go through that nav link. Now, if I get to a location that he wants to get to but can't reach for whatever reason, so let's say, for example, I have this here, drag that up there, and block this nav link. Okay, so that nav there, he can't reach this nav unless he goes for the nav link. So if I get up there, he should run round to that nav link. Hang on. Oh crap, hang on. Okay, so now he'll run round, and although he loses sight of me every time he does this, so it's not going to work that well. Hang on. If I follow him this way around, maybe. Yep, you. Right, so again, he loses sight of me. It's not going to work very well in this case. There you go. So he runs to that nav link there, and he couldn't get up it, so he just gave up, and he's now lost sight of me and just gives up. But what you can do when he reaches the nav link, you can set up some code to make him jump. Now there is an event for that. Navlink proxy. What is the code for this? I forgot now. What is it? I forgot now. Can't remember how you make it link through code. Can't remember. Don't know. Let me Google it. I can't remember what they do with it. Hang on. Oh wait, is it already on there? Hang on. No, it should be. Oh, hang on. Nav. No. Yeah, it's just an event, but how do we get that event? Oh, it's not called. It's called. That'd be. No. Apologies, I'm just trying to remember how you do this. Yeah, smart link reach, but I don't know where the hell the event is. Smart. Where's that event? It's been like years since I looked at nav links. Hang on. Oh, right, you have to make it a mesh with it as a component. Oh, that's long. Okay. So, to do the nav link, this is basic nav link. If you want to do a proper nav link with it jumping up, let's try and get that working. Make a new blueprint class, and we'll do it actor jump up point. Oh, hello. And add a nav link. Probably have to make our own one, don't we? I guess this is not going to work. If I drag this out, I'm not going to see that, am I? Oh yeah, I will. Cool. So in here, we can do add event on... yeah, we need to make our own one. Crap. Not a mesh component. It's a... You have to make a separate component. You have to... Oh dear. I don't know if you actually do this in this. Hang on, let's have a look. No. Navlink proxy. No, hang on. If I can't find it, we have to call it a night. It's getting quite late here. Where is this event? No, jumping is not simple. It's falling down is easy, but jumping and up is not. So not many games do it because it's a pain in the butt. It's weird to look right. Oh, I was half right. Not that. So you drag this nav link out. No, we had previously. Put that up there like that. That As long as it's inside the nav link, that's what matters most. Like that. Cool. Okay. Then in here, you go to Blueprint, add script, and then you click. Yeah, I think you just click that. Then in here, go to override, receive smart link reached. There we go. And the agent, we're going to tell to cast to character. And we'll tell the character to jump. That's essentially the way you do it. So it does that. Let's see if that does it. No, he just loses sight of me too easily. Hang on. Wait, you come back here. I don't know if that sight thing's getting worked. Hang on. Wait, did I have to tick everything in here? We need smart link is relevant. Tick that, yeah. Link direction, we'll make it only go up one way, so it'll go left to right. I can't tell. Right to left. Can't tell. It's too difficult to tell. It's too much green. Oh, what's this? Hang on. Nav link. What's this thing? Oh, right. Yeah. I see. Enabled. And link relevant start. We'll put that there. There. Leave that there. I think this is what you do. Yep, play. Right. Come on, you. Follow me. It's not having it. We're going to do one way. I can't tell which one's which though, because the colours will blend together. Nope. Come on, you. Wait, back here. Might turn off the ability for it to run away from me. Oh, and look randomly. Okay, he's stuck. It's something like this. And it is quite late, yes, as someone just pointed out. Left to right. Link enabled. Smart link irrelevant. Default for default. Should be okay. In a huge random generated map, we must set these jumping point manually. Yeah, so if you're doing a completely random sort of map, precision map, generated map, what you'd have to do is what would you have to do? I mean, you can make things that have obstacles, and if it sees it, it will block it. And like, for example, hang on, let me do another example here quickly before I go to bed. So we see this crate box thing over here. Okay. At the moment, this thing has been told to block the nav mesh. See, it's got a big space around it. If you go down here somewhere, navigation. No, where is it? Put in static mesh component actually. Where is it? 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 Just search for it. Nav. Can affect navigation. So you turn this off like that. So it just gets. It's in like inside the wall thing here. So they'll run towards it and try to run through it. And what you can do is if they detect that they're in front of it, you can make them jump and climb over it. So that is the way you would probably do it, is you have to make it do that. And do a line trace out, basically. When it hits the line trace, it'll jump. That'd be the only way I can think of doing it. If you're doing like a randomly generated map. So if I did that, he would jump over it. Because he would see the line trace he's trying to do is now blocked by something. And he'll try and jump over it. He doesn't see it as an obstacle. He thinks it's a thing he can walk through, so he loses sight of it. It's a long story, but let's try event tick here. Line trace by channel. Get actor location. Get actor forward vector, multiply it by say 200, add those two together, and we'll chuck that into end, and start will go there. But here we will make sure that it only affects like things it can jump over. So at the moment it's set to everything, visibility. It'll just jump like mad. But we'll do it anyway. Why not? Be funny. And if that is true, branch that true there. You can just take it to jump. So then you do get some weird behaviour at this point. See, like they hit the wall. It does that. But if he chases after me and he tries jumping over it like that. But it's something like that without going into too much detail. Okay? So he's trying to jump over me, jump over it to jump to me. Okay? Yeah, there you go. There's one last little tiny tidbit before we do say goodnight, because I am exhausted, is nav modifiers. So nav modifiers are very useful. Here, a nav modifier here. And this nav modifier by default will block stuff. So if you want to block a nav mesh from something, you can use a nav modifier to do that. But it has a lot more usage as well. So in this nav modifier, we can change it. Where is it? Yeah. No, what are we doing? Change its class. Where the hell is its class? Default. There you go, default. So a null class is it blocks it out. So if you want to block out areas of a map so it's not using nav mesh, don't want enemies or AI to go there, you can use this. Useful for like building and things like that, where they could get stuck. But other things might be useful is if you want it to avoid the area unless it has to go through there, like traps and things like that. You can change this to be an obstacle, like that, so it will try and avoid it if it has to. Low height, so if it's got a low, so it is part of the nav mesh, but it's like a low ceiling. So you can tell them to crouch underneath that, for example, if you're clever enough. Null, we know what null is. Default is just leaves it like a default thing. But you can also create your own nav areas. So if you create a new nav class up here, nav modifier, nav, what's it called? Nav area. Here we go. And choose select. And open this up. You can choose the default cost for it. Now, default cost 1 means it'll be like green. It'll look like it's worth the same amount to travel for it. Because the way nav meshes work, it calculates how much does it cost to go a route to something. But if I were to increase this to have a higher cost, like 5, for example, and I told this thing to have this one here, this means that this area is far more expensive for it to go through. So it will go through it only if it's the closest possible one to it. So if it works out if it's cheaper to go this way round or this long way round, it'll choose whatever one is cheapest. This has just increased the height of this. So if you've got like water that you don't want him to go through, if he doesn't want to, but if it's like an emergency and he thinks that's the best way to get into you quicker, you can make it go through that water reluctantly. So that's how you do like reluctance type stuff like that. Likewise, you can make it prefer certain routes as well. So you can change the cost of this to be like 0.1, and it'll always choose the long that route. Well, it won't always choose it, but it'll choose this route probably more so than others. So if I increase the size of this to cover this whole thing here, and even though, let's say, let me put it over here. Sorry. I don't know if this will work because it's still quite cheap. Hang on. What's the best way to show this? Okay, so if I do it like this, right, because this area is cheaper, he'll prefer to go this way around every single time. Okay. And even if he saw me this way, damn it, he got too close. See how he preferred to go around that side of it? Obviously, he's still trying to walk through this. Hang on. There we go. So, even though he saw me down this side, he's trying to go around that side round. Because it's cheaper for him. So that's quite cool. Anyway, that'll do. Let's answer the last questions then. Kairos says, before you go, top 5 simple things worth adding to AI. Rather than things you to add to AI, things to think about with AI, I would recommend in general is simpler is better. AI in most games are pretty basic. They will see the player, chase the player. If the player gets too far away, go back to where they went from. If they see player, shoot player upon sight. There's not much in it, really. They don't vary too much. The other thing I would suggest as well is AI in games. Remember, if we wanted to, we could make the AI win every single battle, no problem. Very, very easily. Remember, you're as a game designer, you're there to make the game fun, not challenging. Okay? So whatever's, always prioritize fun over challenge. Don't think realism. So don't think, oh, the AI would have better aim than that, and they shoot the player and deal damage and aim for headshots, things like that. Don't do that. Think of ways that you can improve the fun in the player in the battle. So there's a few examples of some games that use AI tricks to accomplish that. So for example, in BioShock, enemies will always miss their first shot. The reason why they miss their first shot, well, they're forced to, but the reason why they chose to do that is because they wanted the player to always have a chance. They won't ever get snuck up on and cheesed with a simple like headshot. So they will always miss their first shot. Okay. Pardon me. And there's other little tricks like that all over the place in all various types of games. Um, so like for example, not particularly AI related, but for shooters like Halo, for example, when the gun is being shot by the player, the gun's a hit scan gun, but when it's shot by an enemy, it's a projectile that you can dodge. So it's stuff like that. Always prioritize fun over realism or challenge. Okay. I do often see people go like especially my students will say like, "Oh, I'm gonna make this like really, really hard enemy. He's gonna really beat you up all the time." Like, okay, but is that fun? Like, do you want to do that? Like, I like the Goombas from Mario, and all they do is run around randomly until they see you, then they just run directly at you. Yeah, so you can have a lot of fun by just keeping things simple. So, all right, that goes with all game stuff as well. Simpler is better. Always keep things simple. And always think about also actually just play games and just look at what the AI is doing. Like I mentioned before, not many games actually have AI jumping over stuff because it's a pain in the butt to do. So they just make them drop down and that's it. There's a lot of games where enemies just drop down into the arena and then they just circle around and shoot at you and things like that. They very rarely actually do anything like vaulting or jumping. It obviously happens in some games, but a lot of them don't bother because it's a pain in the ass to do. What else? Use AI directors. So I used one earlier to showcase the leadership stuff. Use an AI director to manage the level that you're in. So if I dropped into this arena here, I'd have an AI director that controls what's going on in the scene. So I've got these AIs doing stuff, but it's a good idea to have something else that's managing the chess pieces and understanding who should be where, what they should be doing. And you can control things like having like attack one at a time. So in my melee AI series, I used one to direct which one should attack next, using something called a ticket system. So you give a ticket to whoever who deserves the attack next based on their circumstances. So use an AI director to help manage that stuff. They're very powerful, really cool to do. AI and Thief series is awesome. You can also replicate it easily with you can do, yeah. For those who are not on the Patreon and haven't seen it yet, but the Stealth AI series covers a lot of stuff like that. So in the Stealth AI series, we do a lot of Metal Gear Solid type AI. So they can hear your footsteps if you get too loud and too close, but if you're crouching, they don't hear it as well. They also have puddles that you can run through and stuff like that, and also have execution, so you can sneak up behind and break their neck. All that stuff is in the Patreon videos for the Stealth AI series, which is just about to finish. We're on our last episode now, so that's coming out tomorrow for Patreon members there. After that one, we've got another AI series coming out. This one focusing more on FPS sort of shooters and AI in that, making it a bit more erratic AI that shoot back at you. I'm planning to do AI throughout the year, so that's one after this one. After that, we'll probably look at animal AI and show how to do animals. We'll see how time permits it. But yeah, lots more AI stuff coming down the road. Turn-based action AI, other stuff, combat wise, yeah, all that good stuff. Okay, right. It is quite late here. It is almost 1 a.m. Jesus, I'm going off to bed now. Thank you everyone for watching. Hopefully you enjoyed this and enjoyed these live streams. We are live again on Wednesday for question time. So if you have any question about game development, Unreal, anything you want about anything at all, come along on Wednesday for that live show. There are new videos coming out every day of this week and every other day of this month. Just keep an eye out on YouTube and on Patreon if you're a Patreon member, getting new content there too. Thanks very much for everyone for watching. What else to expect? You've got the puzzle game series, you've got the Stealth AI series, you've got RTS series, you've got other odd jobs, ladder videos coming out for Patreon as well this week. I've just recorded it literally before recording this or going live with this. So we've got ladders coming out and showing how to do dynamic ladders that you can climb up and change the height of quite easily. So all that stuff is coming out too. Anyway, have a great night. I'm off to get some sleep. See you all next time. Bye everyone.